Algebra 2 Honors, Lesson 5-6, Complex Numbers. Alright. The lesson's objectives are define imaginary number and simplify imaginary numbers. Okay. First of all, let's define what a complex number is. Alright. A complex number is any number that has a real part and an imaginary part. Okay. For example, 4 plus 3i. This is considered real because it's just a real number. Now this is imaginary because it has the letter I. So together, right, this is considered a complex number because it has a real part and it has an imaginary part. Now the definition of an imaginary number. Now before, remember we couldn't have a negative square root. Like the square root of -4, you really didn't know what to do with that, right? If you got this, okay? So now we're gonna talk about what we're gonna do if we have a negative square root, and in order to do that, right, we need to know what an imaginary number is. Right? I represents the imaginary number. Right? I is equal to the square root of -1. Right? I squared is equal to -1. I to the third is equal to -I, and I to the fourth is equal to 1. Right? It's very important that you remember this cycle right here. Right? Because this cycle just repeats. Right? Every multiple of 4, the same cycle just repeats over and over again, every multiple of 4. Alright? And the most important one out of all these to remember is I squared. Alright, I squared you have to remember equals -1. Okay? So let's say I ask you, what's I to the 22nd? Okay? Now since this cycle repeats itself every 4 times, all we're gonna do is take whatever this exponent is, divide it by 4 to find out what your remainder is. What we care about is the remainder. So 4 goes into 22 5 times. Alright, so we'll get 20, subtract, and we'll end up with 2. Alright, this is what's important, the remainder. Okay, because what this means is we're going to have I squared since the remainder was 2, and we know I squared is equal to -1. Alright, so I to the 22nd is going to be equal to -1. Okay, let me do another one real quick. Let's say we need to find out what I to the 31st is. Alright, so we're going to take 31 divided by 4. We'll get 7. Alright, so that'll give us 28. Subtract, and our remainder is going to be 3. Alright, so basically this means I to the third. Right? And I to the third is equal to -I. Alright, what this means is I to the 31st is equal to -I. Okay, so your remainder tells you, alright, basically your remainder takes the place of these right here. You're either going to have a remainder of 2, 3, alright, and if it divides evenly, basically that's I to the 4th. For example, I to the 32nd. If you take 32, you divide it evenly, right, by 4, that's going to give you 8. So you have 0, right? You have 0 as a remainder, right? So just remember, if it divides exactly evenly, it's I to the 4th, which equals 1, right? I to the 4th, which equals 1, right? Or you remember anything to the 0 power, right, is equal to 1. You can also remember that too. Alright, moving on. Simplifying numbers using I. Okay, now simplify the square root of -8 by using the imaginary number I. So you have the square root of -8 and you need to simplify this. What you're going to do is you're going to take an I out, right? If you take an I out, then this -8 becomes positive, right? When you take the I out, if this is your problem, take I out, the imaginary part, right? And then you're left with just a +8. And then just simplify this as usual, right? This would be 2 square root 2, right? So if you break this down, right, this would be 4 times 2. The square root of 4, right, we know is 2. So your answer would be 2i, because that's on the outside, radical 2. Okay? These are here. If we take out an I, then it would be I radical 2. and you can't break this down, so then you're done. Over here, if you take out an I, it'll become a positive 12, and then simplify this as usual. This is 4 times 3. The square root of 4 is 2, so your answer would be 2i radical 3. All right. Over here, take out an I, so you get radical positive 36 now. And then the square root of 36 is 6, so you're going to end up with 6i. That's it. Okay. Our simplifying imaginary numbers. Okay. So write the complex number square root negative 9 plus 6 in the form a plus bi. Well, this, right, if we have the square root of negative 9 plus 6, well, right here, we take out an I, we end up with the square root of 9. The square root of 9 is 3, so we get 3i plus 6, and then just reverse the way you write it, so it'll be 6 plus 3i. That's it. Alright, so write this in the form a plus bi. Well, let's take out the I, that'll become a positive square root 18 on the inside. Alright, the 18 will become positive. Plus 7. Break this down. Well, 18 is 9 times 2. The square root of 9 is 3. So we'll get 3i square root of 2 plus 7. And then rewrite it so that the I part comes second. So 7 plus 3i square root of 2. Alright, simplify the expression 5 plus 7i plus negative 2 plus 6i. Well, right here, what's going to happen is, if we're adding, just add the normal numbers with each other, so that'll give you 3, and then combine the imaginary parts with each other. So positive 7i, positive 6i gives you positive 13i, and that's it. You can't combine these because this is imaginary and this is real. Now if you're subtracting, you have to remember to distribute the negative. So basically this would be 8 plus 3i, stays the same. If you distribute the negative, this will give us minus 2 minus 4i. Combine the like terms with each other, the normal numbers with each other, that'll give us 6. Then the imaginary parts with each other, that'll give you negative I. Okay, easy. Over here, distribute the negative. So this will be 7 minus 3 minus 2i. These two are like terms, so that'll give you 4 minus 2i. Okay. Over here, just combine the like terms, these right here. So that'll give us 4 minus 3i. Our multiplying complex numbers. So just multiply the regular numbers with each other. That'll give us negative 20. Then I times I gives us I squared. Then you have to remember, I squared, is equal to negative 1. So you have to replace I squared with negative 1. So negative 20 times negative 1 gives us positive 20. That's it. Okay. Now let's take a look at this problem. Now we're multiplying this with this. So basically we have to FOIL. Multiply the 2 with the negative 3. That gives us negative 6. Multiply the 2 with the positive 5i. That'll give us positive 10i. Multiply the 3i with the negative 3. That'll give us negative 9i. And multiply the 3i and the 5i. And that'll give us positive 15i squared. Combine like terms. We'll get negative 6 plus I. And then I squared, remember, is negative 1. So 15 times negative 1 will give us negative 15. Combine the like terms, these two. So we're going to get negative 21 plus I. And that'll be our answer. Okay? Let's do another one of these real quick. Let's take a look at these on the bottom right here. Well, we're multiplying 12 times 7. It gives us 84. I times I is I squared. Remember, I squared is negative 1. So 84 times negative 1 gives us negative 84. Over here, we need to FOIL. 6 times 4 is 24. 6 times negative 3i gives us negative 18i. Then we have Negative 5i times 4 gives us negative 20i. Negative 5i times negative 3i gives us positive 15i squared. Right? So we have 24. This will give us minus 38i, because we're just combining them. Remember, I squared is negative 1, so 15 times negative 1 gives you negative 15. Combine the like terms, right? So we're going to end up with 9 minus 38i. Alright, dividing by a complex number. Okay. Now, if we're dividing by a complex number, now remember I, you can't have I in the denominator. Alright, so remember this, cannot have I in the denominator. Alright, I is kind of like the square root, you can't have in the denominator. Right? So what happens is, how do you get rid of this I? Right? Well, if it's just 2 times I, so since I is multiplying with another number, all you have to do is multiply the top and the bottom by I. Why do we do that? So we get 5i on top, but look what happens on the bottom. 2 times I times I, well, it doesn't give you 2i squared, and we know I squared is negative 1. Right? So basically we're going to get 5i over 2 times negative 1, which is negative 2. Alright, so basically our answer will be negative 5i over 2. And that will be our answer. Okay? Let's take a look at this one right here. Now, over here, since we have 1 minus 5i, right, it's different from this. Over here, I was just multiplying with another number. Over here, we have a complex number on the bottom. If you have a complex number on the bottom, what you're going to have to do is, you're going to have to multiply the top and the bottom of the fraction by what's called the conjugate, okay? And the conjugate, alright, it's just the same exact thing, but the opposite sign. So if this is 1 minus 5i, the conjugate would be 1 plus 5i. Alright, so this right here is called the conjugate. Alright, make sure you remember that, that's very important. So just take the opposite sign of whatever this complex number is, and this will be called the conjugate. So multiply both the top and the bottom by the conjugate. So on top here, we're going to have to FOIL, alright, because we're multiplying, right? So basically, pretend these are in parentheses. So we're FOILing. 3 times 1 is 3. 3 times positive 5i gives us positive 15i, right? And then we have the 2 times the I, right? 2i times 1, that will give us 2i, positive 2i. Then we have the 2i times 5i gives us positive 10i squared. Combine like terms, we get 3 plus 17i, right? And then we know I squared is negative 1, so this will become minus 10, right? So these two are like terms, so we'll get negative 7 plus 17i, right, on top. Right, so all this work was just the top of the fraction. Now the bottom right here, now I'm going to give you guys a shortcut. When you're multiplying conjugates together, so everything's exactly the same, right, and the signs are just different, all you have to multiply are the first ones together, that'll give you 1 in this case, and the last ones together, that'll give you negative 25, right, I squared. Then I squared we know is negative 1, so basically we're going to get 1 plus 25, which will give us 26. So our answer will be negative 7 plus 17i over 26. But you have to remember, right, when these are conjugates, that's when you could just multiply the first ones with each other and the second ones with each other, right? When they're not conjugates, right, you have to completely FOIL the whole thing. So remember that. So I'll do one more. So let's take a look at this problem right here. I'll do C. So we have 5i divided by 2 plus 2i. Well, since this is a complex number, I'm going to need to multiply by the conjugate, which will be 2 minus 2i. So multiply by 2 minus 2i on top. Alright, so then I will distribute. Alright, since I'm multiplying, I'm just multiply here and here. So that's going to give me 10i minus 10i squared. And we know I squared right here is negative 1. So negative 10 times negative 1 will give us positive 10. So the top will be positive 10, right, plus 10i. Negative 10 times negative 1 gives you positive 10. And I'm rewriting it so that the imaginary part is in the back. Now let's deal with the bottom. Since these are conjugates, we could just multiply the first ones with each other, 4, the last ones with each other, minus 4i squared. Then we know I squared is negative 1. So this will become 4 plus 4. So we'll get 8. So we'll get 10 plus 10i over 8. Now here's where you have to be careful. On a test, you're not done here, because you have to recognize on top what can we factor out on top here that will reduce with the bottom. We can factor out a 2, because then we'll get 5 plus 5i over 8. And the 2 and the 8 reduces. That's why you have to factor out the 2. So then we'll get 4. So our final answer will be 5 plus 5i over 4. Alright, so this will be our final answer. Okay? So you always have to check, can I factor anything out from here that will reduce with the bottom denominator? Okay? Alright, finding our complex solutions. Okay? So right here, what we're going to do is, we have 4x squared plus 100 is equal to 0. Alright? If I try and check to see, if I factor out the GCF, I'll get x squared plus 25 is equal to 0. Now this isn't a difference of squares, so I know, well, I can't factor this, so I'm going to have to use the square roots method. So let's start with the problem again. Now the square root method, the square roots method, like we talked about in 5.5, we're trying to get x squared by itself. So we're going to minus 100. We get 4x squared is equal to negative 100. Divide by 4. X squared is equal to negative 25. Now we're going to square root both sides. Now remember, like we talked about in 5.5, when you square root both sides, you need a plus and a minus. Now since this is a negative square root, we're going to have to take out an I, and then we'll end up with square root 25, and the square root of 25 is 5. So our final answer will be positive and negative 5.